Hello students and welcome to my YouTube channel Forstra. In this video we are going to solve AP Physics 1 free response questions that is being asked in 2025. So let's begin. Let's solve question 3 version J. Students are investigating balancing system using the following setup. Students have a spring scale of negligible mass that is fixed to one end, okay, this side. So other side, student have to hang the mass of m naught. The hooks are provided at different distance from the center. This is the stand on which the meter scale is. In this, we have to describe an experimental procedure to collect data that would allow a student to determine m naught, include any step necessary to reduce the experimental uncertainty. To design the experiment around this, when this mass m naught is hanged at this point, let us say m naught at this position, and from the center everything would be measured because this is the axis. So this is at point D, this center, this is point D, and this spring scale position is fixed. So this is at 0.5 meter away from the center. So this is half meter and this is at D distance from the center. And when this is horizontal, the scale is horizontal, the forces would be balanced. So let's see what are the forces. Force would be on a spring scale. So it would be represented as Ft, the reading of it. A reaction on this meter scale due to this frame, but that would be axis, that would be passing from the axis, so it won't contribute in the torque. And this m naught g is a force, gravitational pull of this block would be in the downward direction. So what we are going to do here, we are going to frame an experiment where we are balancing the torque at the left side and at the right side. Hang the mass m naught at any location, any hole, first at any hole, let us say at this point or this point, any hole, and note the distance from the stand in meter. So it would be D. And the second step would be balancing the scale. The meter stick, or you just write meter stick. It should be parallel to earth. Or the table on which you are conducting the experiment. So it should be parallel. It should not incline to one end or left side or right side. Not inclined to any side. And the third is note the reading from spring scale. And this is Ft. Determine how the data collected in part A could be graphed and how the graph would be analyzed to determine m naught. So we know that at equilibrium that the torque is equal to 0, and because of two forces acting on this, Ft and m naught g, and this is r because the distance, perpendicular distance from the axis is 0, that's why we don't consider this because the torque would be 0 due to this. Ft into 0.5, and this is anti-clockwise, that's why it is positive, and this is clockwise, so it is negative. So negative of m naught into g into d is equal to 0, and Ft into half is equal to m naught g into d. We have to find m naught, or I can write it as Ft is equal to twice of m naught into g into d. So we can plot a graph on x-axis. So this is y is equal to mx. On x-axis it would be d distance, and on y-axis it would be Ft, and the slope would be equal to 2 m naught g. Slope can be represented as s. I can write divided by 2g. This would give me m naught value. So slope divided by 2g, this I get m naught value. Let's come to figure 2, which is now this again another meter scale, and it is a spring scale, and these are pegs through which this theta can be changed. So this plot between theta and ft is given. Ft is representing the tension force. Ft is the tension force on this spring. This is ft. This is theta. At different theta, different st we get. The student correctly determined the relationship between Ft and theta given as Ft is equal to 5 mg upon sine I. The student create a graph with 1 upon sine theta plotted on the horizontal axis. So this is horizontal axis. Okay, this is also theta. Indicate what measured or calculated quantity could be plotted on the vertical axis to yield a linear graph whose slope can be determined to calculate the experimental value of m. I'm just rearranging this equation, so it would be Ft is equal to 5 mg upon 6 into 1 upon sine theta. This is x-axis, this is on x-axis, and this is on what we can do, y is equal to mx plus c. So x is already 1 upon sine theta, and we can plot Ft on the y-axis. Ft. So Ft I am using on y-axis, on the vertical axis. So it would be y, and this is slope we get from this plotting. So this would be slope. On the blank grid provided, we have to plot it. So to save time, I have already plotted on Excel. As you can see, this is 1 upon sine theta and this is Ft, and the plot between them. So these are the points I am getting, and this is the best fit line. So let me just write the value from this. So these are the points I am getting, and we can draw a line, a best fit line passing through this. Draw a straight best fit line that we have already drawn. Using the best fit line that you drew in part C third, calculate an experimental value for the capital M. So we have to find capital M. Let's find the slope first. Take 2 points. This is the point 1 and I am taking this as the point 2, and we have to write the coordinate of it. It would be 2.5 comma 19.5, and this is around 1.3 comma 10. Slope is equal to y2 minus y1 upon x2 minus x1, and when you put the values, it would be 19.5 minus 10 divided by 2.5 minus 1.3, and when you solve it to 7.92. This is slope, and since we plotted Ft versus 1 upon sine theta, slope is equal to 5 mg upon 6. So this is equal to 5 mg upon 6 is equal to 7.92. So m would be equal to 6 into 7.92 divided by 5 into 10. Mass is equal to 0.9504 kg. This is the mass of the meter scale used in this experiment. Thank you for watching. Like the video, comment it, and subscribe my channel. If you want to learn from me, whether it's AP Physics 1, 2 or C, Mechanics part or E&M, you can connect me on this WhatsApp number, or you can email me on fostra.physics@gmail.com. See you in the next video.